Hi everyone. In the last session, we have started the concept of storage classes. We discussed that there are four types of storage classes. They are automatic storage class, register storage class, static storage class, and external storage class. We defined that a storage class determines the storage of a variable, default value, scope, and lifetime of a variable. Remember that every variable will consisting of two basic properties, or we can say characteristics. The first one is the data type and second one is the storage class. Whenever we declare a variable of type integer a semicolon, it indicates the type of the variable a is integer and its storage class mainly describes what would be the default value and where the variable is going to store and at how much time it is going to live and what is the area where we can use or access the variable a. Now, in today's session, we discuss each and every storage class in detail. So, let us go to the storage classes one by one. So, first one, we are talking about automatic storage class. See, for each and every storage class, we are going to talk about the first one is the class, and second one is name of the class, and third one, we are going to discuss about the default value. Default value. Next one, what is the storage? And next, scope of the variable. And the last one is lifetime. So these are the basic things. Mainly, we are talking about default value, storage, scope, lifetime. The first two things indicates the type. So first, class. What is the class? Class indicates we are using the keyword auto. There are four letters of keyword which is used to represent automatic storage class. Auto you have to write. It indicates that automatic, right? Now, what is the default value of automatic storage class variable? The default value of automatic storage class, whenever you don't initialize, is garbage value. Garbage value, that is nothing but unknown value. Now, storage, where the variable is going to store. Automatic storage class variables are going to store in RAM, random access memory, right? Now, what is the scope? The scope of automatic storage class is within the function in which it is declared. Within the function, or we can say another one is block. Within the function or block in which it is declared. Now, what is the lifetime of a variable or start automatic storage class variable? It is within the function. Within the function till the function terminates, or I can say within the function or till the function terminates. Till the function terminates. See here, basically we are talking about the properties default value. What is the default value? Garbage. Where it is going to store? Primary memory, or I can say random access memory. What is the scope of a automatic storage class variable? Within the function or within the block in which it is declared. What is the lifetime of a variable? Till the function terminates. Whenever the function gets terminated, the life of the automatic storage class variable will gone. So these are the basic properties of automatic storage class. We will see in detail with the example program. So before moving on to the next storage class, so let us have a discussion about local variables and global variables. Why? Because so automatic storage class mainly talking about the local variables. So whenever the variables are local in nature, then the default storage class for all the local variables is automatic. For example, if I write main opening brace, here I'm writing like this integer a and second one is float b. See, if you observe, for the first one I'm writing the keyword auto, for the second one I'm not mentioning any auto. See here, there are two variables which are declared in the main. One is the variable A, another one is B. For the variable A, here we are mentioning the type. Okay. So along with the type, here I have mentioned the keyword auto. Means that explicitly we are saying that the storage class of the variable integer A is auto, or we can say automatic. Now, when you consider the second statement float B here, I didn't mention anything, but even though if you don't mention anything, by default, the storage class for the float variable B is automatic. So please remember that for all the local variables, even though you don't mention the keyword auto, they are by default comes under automatic storage class. Why? Because all the local variables by default comes under automatic storage class, right? When you consider the scope of the variables A, B is this is the scope, right? This is the scope, or we can call it as the function scope. Why function scope? Why? Because whenever this function terminates, the lifetime of the variable A and B lost. Now, what is the area in which variables can be accessed? This is the area, right? Scope as well as the lifetime seems to be similar, but there is much difference. Don't confuse. Lifetime is different and the scope is different. Scope is the area in which a variable can be accessed. Lifetime is the period of a variable, or the time during which a variable exists. So in the example programs, clearly I will explain the main difference between the scope and lifetime, right? Now, the scopes can be divided into three types. A scope can be, just now I said, no. The first one is function scope, second one is block scope, and third one is program scope. For example, here I'm writing the program roughly like this: hash include stdio.h. Okay. Now I'm saying that integer a equals to 10. Next I'm writing integer main, opening brace. Here I'm saying integer b equals to 2. After this, again I'm writing opening brace, here integer c equals to 3. Okay. Now closing brace, right? You see here. This is block scope. This is block scope. Variable c comes under block scope. And this part comes under function scope. Why? Because the variable b is used in the main. This is function scope, right? Now, what about this? This is we call it as program scope. Program scope. This is the part outside the main. This is the part outside the main. The variable a comes under program scope. So a is accessed and throughout the entire program. B is accessed only within the main. C is accessed only within this block, right? So these are the different types of scopes, or we can say visibilities. Function scope, block scope, and next one is the program scope. So before moving on to the register storage class, briefly I can say that an automatic storage class is specified by using the keyword auto. All the local variables comes under automatic storage class by default, even though you don't mention the keyword auto, right? When the variables are in the local in nature, then the concept of automatic storage comes into the picture. And the storage class of the automatic storage class is primary memory, or I can say random access memory. The default value, we said that garbage value, and the scope, I said that. So within the function, or we can say within the block in which a variable can be accessed. What is mean by the lifetime of automatic storage class? Till the function terminates. The lifetime of a variable exists only within the function. When the function is terminated, then the value of the local variable is also destroyed. Now, come to the next storage class, register. What do you mean by the register storage class? Right? So here I'm not mentioning the class and name of the class. Why? Because class is nothing but a register keyword you have to use. and the name of the storage class is again register. Here mainly we are talking about the default value. What is the default value of register? The default value again same as automatic storage class variable, that is garbage value. Okay. Now the second thing we are going to talk about is the storage. Where it is going to store? It is going to store in CPU registers. This is very important, CPU registers. And third one is scope, and fourth one is lifetime. See, scope is similar to automatic storage class variable. That means within the function, the variable can be accessed within the function or block in which it is declared. What is the lifetime? Till the function terminates. Same, till the function terminates. It is similar to automatic storage class variable, but the only difference is the storage of automatic storage class variable is random access memory, but here the storage is CPU registers. Right? Now the scope here I can say within the function or within the block. Instead of saying like this, we can also use the term local scope. Okay, automatic storage class is also having the local scope. Register storage class also having the local scope. They are having the default value garbage. Register storage class also having the garbage value as the default. Lifetime is also similar. The only thing is the storage. So this we will see in detail. Now we will see the register storage class in detail. See here I am writing the program hash include stdio.h. Okay, we write like this, integer main. Here I am writing register int I equals to 1. Now I am writing that printf %d I, return 0. Okay, closing brace. This is one program. Here I am writing the same program hash include stdio.h, right? So int main opening brace. Here I am writing just integer I equals to 1. I am writing printf %d I, return 0, closing brace. You observe this. What is the difference between this and this? If you observe this here, there is no storage class mentioned, right? Here we have the storage class register. Remember that register storage class is specified by using the keyword register. Here, whenever you don't mention the storage class here, by default it comes under auto. Means the storage class of I is automatic, and the storage class here int I is register. Then what is the difference? See, the main difference is only the execution speed. If you use the concept of the register, then the variable is going to store only in CPU registers rather than storing the value in random access memory, or you can say primary memory. When the values are stored in the CPU registers, then the CPU is going to take the values from directly registers and it is going to execute the program very fastly. Only the execution speed is different when you use the concept of register storage class. See, we will see an example here. So assume that this is the area, we call it as secondary memory, and this is the area we are calling it as primary memory, or we can say random access memory. Here we are taking CPU, right? This we are talking about CPU. Whenever you save or whenever you write a program, without saying whenever you write a program, that program is stored in the primary memory or random access memory. For example, just now I have written the program that hash include, right? We have written one program now, stdio.h and int main Assume that we have written like this. Here you have declared a variable, assume that integer I equals to 1 and printf percentage d I. This is a simple program you have written, and you have saved the program as first.c. You have saved the program. All the saved programs are stored in secondary memory, or we can say hard drive, or we can say solid state drive, SSD. So this is the scenario when you save the program. The saved programs are stored in the secondary memory, right? Whenever you want to execute the program, then this program must brought from the secondary memory into primary memory. That means random access memory. Here, all these program statements are transferred to random access memory, right? From this random access memory, the CPU is going to fetch the instructions one by one, and it is going to execute the program. So whenever we execute the program, the CPU is going to execute the program by bringing the program from secondary memory into primary memory, or we can say random access memory. This is a general scenario, right? Now, instead of using the automatic storage class or any other storage class, if you use here the keyword register, then what happened is, so instead of storing this variable in the RAM, a random access memory, the variables directly stored in CPU registers. Please remember that the CPU is going to contain its own temporary storage area. Those are known as the registers. Registers are very near to the CPU. The CPU may also consist of another one cache memory. Cache memory is going to store the repeated instructions. So other than cache, we are talking about the registers. Registers are very near to CPU compared to cache. So what I want to say is, in CPU we have cache memory as well as the registers. So compared to cache, registers are very near to the CPU, and the CPU is going to store the immediate needed data in the registers. Whenever we use the storage class register, the variables are directly passed to the register, and from the register the CPU is going to access the values, and fastly it is going to compute the values, and it is going to execute the program very fastly. The only difference I want to say is, whenever you declare the variables other than register storage class, generally the CPU is going to take all the instructions from primary memory for the execution. Whenever you use the concept of the storage class, those storage register storage class, those variables are stored in the CPU registers. So then, instead of going to the RAM random access memory, the CPU is going to search the values in its own registers, which are very near to the CPU, so that the time is reduced, the taking time is reduced by using the concept of the registers. So the main thing is the execution process. And another important thing is, the area in the primary memory is addressable. Means whenever you store the variables in the random access memory, every memory location is going to have an address. But for the CPU registers, there are no addresses. If you specify the addresses for the registers, it will give the compiler error. Please remember that you can't use scanf statement to read the particular value into a register storage class variable. Why? Because they are not having any addresses. When you use the concept of RAM, or when you use the concept of automatic storage class variable, those values are stored in the primary memory. Those are addressable. You can mention the address operand there. But in register storage class, addresses are not valid. This is very, very important. Now, after this register storage class, we move on to we will see static storage class variable. A static storage class variable is specified by using the keyword static. Now, mainly we discuss about what is the default value of static storage class. The default value is 0. So previously we have seen the register storage class. What is the default value? Garbage. For automatic, also garbage value. What is the storage of automatic storage class variable? Random access memory. What about register storage class? It is CPU registers. Here, the storage of static variable is again as automatic storage class variable random access memory. And next, scope. Scope here I can write local. Local in the sense within the block or function in which it is declared. Now coming to the lifetime, what is the lifetime? The lifetime is till the program ends. Till the program ends. See here, for automatic storage class variable, scope is local. Scope is local. For register also, scope is local. For static also, the scope is local, right? When you talk about the lifetime, the automatic storage class lifetime is, what do you say, till the function terminates. For register storage class, the lifetime is till the function terminates. But when you come to the static, the lifetime of static variable is till the program ends, till the entire program ends. And its default value is 0. We will see in detail by writing C programs, right? So this is a simple discussion about automatic storage class, register storage class, and second one is static storage class. In one word, I can say that a static storage class specifies that the value of a variable persists or retains between the function calls. Even though when you are jumping from one function to another function, the value of the static storage class variable remains constant. Every time the value is not reinitialized and it will not be started execution every time. So we will see the main example for static storage class and other remaining storage class variables in the next class. With this, I'm going to close the session. Thank you for watching.